Hello everybody, I'm Nick, and this I'm going to explain what are source code analyzers in .NET, also known as Roslyn analyzers. I'm going to explain how they work and how they help you write better, cleaner, and safer code. And then I'm going to give a couple of my personal recommendations for the ones I use to help me write more performant code and safer code in general. If you like that type of content and you want to see more, make sure you subscribe and hit the notification bell to get alerted when I upload a new video. So if I go to the program.cs, you see green squiggly lines and 4 green dots here. Those are both tips or hints produced by my IDE writer, and they're based on source code analyzers that writer is using, and they're built in my IDE. But this is just one of the types. There are also extensions or plugins that will perform code analysis in your code, and this is all design time as you're writing. And also there are NuGet packages, so you can install a NuGet package and have it analyze your code. There's also built-in ones in .NET itself. So if I do async task here, the .NET async source code analyzer will look at this and say, you're not actually awaiting anything in this method. So I think that you should actually either use await or remove this async. And if I build the project, you will actually even see it during compilation here, and it has a code, the code CS1998. Now, this is a warning because it's yellow, arrows are red, I think hints are green, and so on and so forth. But the idea is that there is some piece of code behind the scenes that is looking at what I have open in my IDE, performing code analysis or source code analysis, and to give me hints. So that's the first part. And the second part is, let's say I have something like var name equals Nick, and I want to print my name in the console. Now there's these 4 dots here that when I do, for me it's alt enter because that's what I have configured, but for you it's whatever you have for quick actions. And if I do that, it says to const, and we'll change this to a const. This change is based on a source analyzer as well. Source analyzers have 2 parts. The first part, which is I'm going to inspect your code and see what is wrong or what could be better, and then I'm going to help you refactor your code by providing a refactoring on that analysis. And this is an example of how we can use a source code analyzer to refactor our code. And that's basically what source analyzers are: IDE based, NuGet based, extension based, or just .NET compiler built-in based. Those I think it's 4 things. And in my personal opinion, you probably shouldn't use the extension-based ones, the ones that are effectively added in your IDE. And the reason is actually quite simple. If I want to take this code that has new warnings, new errors potentially, a bunch of stuff from the analyzer that I installed on the extension, and I want to have it run as part of my CI/CD deployment or CI/CD building of the project, well, if I have marked, let's say, this warning as an error on my IDE, or if I have a bunch of new warnings or errors in my IDE, they're all going to be ignored when I go to the CI environment, because the CI won't perform as the compiler will do. However, if I have them as NuGet packages, all of them will actually be honored as part of your .NET build in CI. So for me, the preference is NuGet package-based analyzers. Now, let me show you a couple of things of how cool they can actually be. And we're going to talk about third-party analyzers now, things that me, you, and everybody can actually write if you can deal with Roslyn's C# syntax and publish them as NuGet packages and provide a better developer experience for everybody. So I'm going to make a method here, a public void write in console. And I'm going to say var name equals Nick. And actually, let me just call this method here. So, let me turn this into a static write in console. Actually, you know what? In order to do this properly, I'm going to say public class application, and I'm going to have the method here as a non-static method. Then I'm going to say var app equals new application, and then I'm going to say app.write in console. Here we go. And now here I have this, and then I'm going to create an action based on the lambda syntax. I'm going to say console.writeLine name, and I'm going to say action invoke. Now, why do I do that? I do that to show you something. I'm not doing it because I think that's how you should write this code. You can just normally call this, but I'm demonstrating the scenario where you have a lambda that is using something from outside of its scope. I'm going to explain why. Many of you might actually already know why. So if I now go ahead and run this code, you will see that it will print Nick at the console. However, to my eyes, there's something severely wrong with this. I'm using a variable here called Nick or name, which is outside of the scope of the lambda function, and I'm using it inside the lambda function. Now, if you don't know what closures are, you are effectively shooting yourself on the foot here, because you are allocating memory, more specifically 88 bytes here, to the heap that you shouldn't. Because let's say an alternative would be, if that doesn't need to live outside, to just do this. You go here, and this is now inside the lambda. And what is the difference? Okay, let's show you what the difference is. I'm gonna go in dependencies and search for CLR heap allocation analyzer. And this is a .NET analyzer, a Roslyn analyzer. And as you can see, the moment I installed it, it noted two things. The first thing is that compiler will emit a class that will hold this as a field to allow capturing of this closure. And the second thing is that heap allocation of closure captures name. Now, you probably don't know what a closure is, but you might have seen during debugging stack traces something called a display class in your stack trace. Display class is effectively a closure class. If I actually show you this in sharp.lab.io, which will show you the load code, you might understand why it's doing this. So here I have two methods. One is having the closure, one doesn't have the closure. And if I search for the one that does have it, you'll see that it actually creates a display class and instantiates it, sets the value name to Nick, and then uses it in the new action. And you can actually see the display class created here. It's a class with the sole purpose of having this name here and then calling the actual write line, while the alternative doesn't do that. It will just create the new action, and you can see that the string has been inlined here without creating any new variable. So this will save me 88 bytes of allocated memory. Now, you might not know it, or you might have just started using, understanding closures, but using the analyzer can actually help you understand that, hey, there's a heap allocation here, fix it, and you can fix it by either moving this here or by using the refactoring proposed, which is to turn this into a const. Turning this into a constant will actually fix the heap allocation. So this analyzer just saved memory allocation without even knowing exactly why or how. Of course, it comes with other baggage. It will also tell me here that you're explicitly newing up a reference type, and there's going to be an allocation for that. But that's absolutely fine. You can't really get around that. But in things like the one I just showed you, the closure, it will actually help you save memory. Now, another thing I'm doing quite a lot, and actually let me just comment this out, because if you want to get the source code, you can see it. Another thing I'm doing quite a lot is using reflection for not for fun, it's not shits and giggles. I'm actually using it in a very efficient way and a very performant way for metaprogramming purposes. But let's say you have something like this, where you have a name property, and I'm going to turn this into a private, and it's the application name, so analyzer app. Actually, let's have this as public instead. And if I go here and say var app name equals app dot, I could do name, but if I want to get this with reflection, I would do get type dot get property. By the way, this is not a valid reflection usage. You just call the variable, but I want to show you something cool from the analyzer. Is get property name. So this goes here, and then I'm gonna say get value app. Here we go. And I'm gonna say this is definitely not null. So I have the app name now, and I can do console.writeLine app name. And when I do that and run, you will see I'm gonna print analyzer app in the console. Now, what happens if this was private, let's say, and the person owning the library or the class changed this to a new name? Nothing changes in my code. So if I run this, my code will go boom, but I wouldn't know about it. However, if I go here in the NuGet packages and search for reflection analyzers. And I install this one. The moment I install it, you see these yellow squiggly lines here. And it says that the reference member name is not known to exist to the application. So it analyzed the class and it detected that this doesn't actually exist. And in those scenarios, because those warnings also have a code, in this it's refl009, I could actually have a new file here called the .editor config file. And if I say here that for all CS files, I want to have .net diagnostics the code, which is refl009, yes, severity equals error. Now, oh, sorry, is it diagnostic? Then suddenly my code treats this as an error and the project won't build because I'm preventing it, because now this reflection is not valid, right? If I change this to new name, it is. And it actually comes up with a second warning, which is, hey, you probably want to use name of, and it also has a refactoring. So if I use that, I'm using name of, so there's no way to go wrong here. And the last thing is you might want to also specify flags to get better performance and less fragile code. So let's go ahead and do that. It will add a few flags here. So it's declare only, instance, and public. So just like that, it helped me write better reflection code, which, you know, sounds like an oxymoron because you're using reflection, but it does make your code safer and also more performant, because these flags will actually help your performance as well. And if you wanted to turn this back into a warning, you can do so here. And remember, these things, when compiled with your project, will actually also be there in CI. So if you wanted to treat this as an error during continuous integration, it will cause your build to fail and the code would never go to production. So it will safeguard your project like this. Now, if you want to see a video on how you can write your own analyzers, please let me know, because I find it interesting and we might want to dive into that in the future. That's all I had for you for this video. Thank you very much for watching. Special thanks to my patrons for making videos possible. If you want to support me as well, you're going to find the link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. And I'll see you in the next video. Keep coding.